Today our video is talking about how to perform long division. We're still in Unit 1, so we're coloring purple. Alright, and then we have some steps here. They're already filled in on my paper, so you're going to need to fill those in. So the steps for long division, first thing we need to do is set up the division problem. So we're given a fraction and we need to turn it into a division problem. Then we're going to multiply, subtract, bring down, and repeat. So those steps should be familiar to you. You should have done this at some point in your math career, but it might be have been a while, so we're definitely going to go over it again. Alright, so if we look at 5/9, our little frog here is telling us the denominator goes outside and the numerator goes inside. So the numerator is the number on top, and the denominator is the number downstairs. So I kind of think about denominator downstairs. They both start with D. Denominator is downstairs. Okay, so we put the numerator on the inside, that's 5, and the denominator on the outside, that's 9. Okay, and then we think, how many times does 9 go into 5? Well, 9 is bigger than 5, so the answer is 0. We can fix that problem by adding a decimal point and a 0. When we add a decimal point here, we're going to add a decimal point here. Now think, how many 9s are in 50? So 9 times what gets me pretty close to 50? Well, 9 times 5 is 45, and that's pretty close to 50. So now we're on the multiply step. 5 times 9 is 45. Then we're on the subtract step. So 50 minus 45 gives us 5. We don't have anything to bring down, but we still have a number here. So we can add a 0 and bring it down. And then we repeat. So how many 9s in 50? Well, we said about 5. 5 times 9 is 45. Subtract is 5. And then bring down. You guys might start seeing a pattern here. 9. How many 9s in 50? It's 5. 5 times 9 is 45. We subtract and we get 5. So this one is just going to go on and on and on forever. So our answer to the division problem is 0.555 repeating. And if we were to round that to the nearest hundredth, right, we could underline the hundredths, look 1 to the right, and we would have 0.56, because the 5 here would make that 5 round up to a 6. All right, example number 2, we have 17/20. The numerator goes inside, 17, 20 goes outside. First question I asked, can I fit a 20 into 17? Nope, 17 is smaller than 20, so we have to add a decimal point and a 0. How many 20s fit in 170? We can count. 20, 40, 60, 80, 100, that's 5. 120, 6, 120, 140, 160, that's pretty close. 180, that's too much. So it's 160, so that's 6 20s. So we add that decimal point. We have 6 20s. That was 20, right? 20, 40, 60, 80, 100. That gave us 5. 120, 140, 160. Sorry, 8. Miss Drexel can't count. That's 8. I'm glad I double-checked that. So 8 times 20. 8 times 2 is 16. And then we have an extra 0. So it always pays to check your work. Subtract step, 170 minus 160 gives us 10. We don't have anything to bring down, but we can add another 0. We bring down that 0. 20 into 100, again we can count. 20, 40, 60, 80, 100. That's 5. They're 5 20s. So 5 times 20 is 100. And we subtract, and that's 0. So we're done. As soon as you get a 0 or you recognize a pattern, you're done. All right, let's look at example number 3. We have 8/7. So again, numerator goes inside, that's the 8. Denominator on the outside. So first question, do any 7s fit into 8? Well, yes, 1. We can fit 1 7 into 8. So now we multiply. 1 times 7 is 7. 8 minus 7 is 1. Add a decimal point and a 0. And then we can do the bring down step. And when we add a decimal point here, we need to add one directly above it. How many 7s fit into 10? 1. 1 times 7 is 7. And then we're at the subtract step. 10 minus 7 is 3. And then we're at the bring down step. How many 7s in 30? 7 times 4 is 28. So 4 times 7 is 28. We subtract. We get 2. Do another bring down. This can go on for a very long time. How many 7s in 20? Well, what times 7 gets us close to 20 but not over it? 2. 2 times 7 is 14. Subtract, we get 6. So this could go on for quite a while. So we can go ahead and stop right there. We've got 1.142. And if we were to round that to the nearest hundredth, so we look at the hundredths place and we go 1 to the right, that 2 says leave it alone. So we have 1.14 as our final answer. All right, last one, 7/6. So again, numerator goes inside the house. There's the 7. Denominator goes outside. Any 6 fits into 7? Well, actually, yes, 1. 1 times 6 is 6 for that multiply step. And then we're at the subtract step. 7 minus 6 is 1. We add a decimal and a 0, so we can do the bring down. How many 6s fit into 10? Just 1. 1 times 6 is 6, and we subtract. 10 minus 6 is 4. And we're at a bring down. So how many 6s in 40 without going over? 6 times 6 gives us 36. Subtract, we get a 4. We can bring down. We get 40 again, so we're starting to get this pattern. 6 times 6 is 36. Subtract is 4, so we get that pattern again. This is going to start repeating these 6s forever and ever and ever. So our answer is 1.166 repeating. And if we were to round that to the nearest hundredth, we would look at the 6 and we would go 1 to the right. That 6 means the 7 needs to round up. So we have 1.17. And that's all for today.